Welcome to today's Leetcode problem of the day, reverse substrings between each pair of parentheses. Hey everyone! Welcome to today's Leetcode problem of the day. Today, we're diving into problem number 1190, reverse substrings between each pair of parentheses. Let's start with the problem statement. You have a string S that consists of lowercase English letters and parentheses. Reverse the substrings inside each pair of matching parentheses, starting from the innermost. The final result shouldn't have any parentheses. Example 1. Input, S equals open parenthesis A B C D close parenthesis. Output, DCBA. Steps. First, find the innermost parentheses, which is open parenthesis A B C D close parenthesis. Reverse A B C D to DCBA. The string becomes DCBA. Example 2. Input, S equals open parenthesis U open parenthesis love close parenthesis I close parenthesis. Output, I love you. Steps. First, find the innermost parentheses, which is open parenthesis love close parenthesis. Reverse love to EVOL. The string becomes open parenthesis U open parenthesis EVOL close parenthesis I close parenthesis. Reverse the outermost part, UEVOLI to I love you. Example 3. Input, S equals open parenthesis ED open parenthesis ET open parenthesis OC close parenthesis EL close parenthesis. Output, LEETCODE. Steps. First, find the innermost parentheses, which is open parenthesis OC close parenthesis. Reverse OC to CO. The string becomes open parenthesis ED open parenthesis ETCO close parenthesis EL. Next, reverse ETCO to OCTE. The string becomes open parenthesis EDOCTE close parenthesis EL. Finally, reverse the entire string, EDOCTEEL to LEETCODE. Here are the constraints. 1. The length of the string S is between 1 and 2000 characters. 2. The string S contains only lowercase English letters and parentheses. 3. All parentheses in the string are balanced. To sum it all up, this problem is all about carefully reversing the substrings within each pair of parentheses, starting from the innermost and working your way outwards. By breaking the problem down step by step and handling each pair of parentheses, you'll be able to get the correct result without any parentheses in the end. Let's look at some examples. Let's start with example 1. Our input string is open parenthesis ABCD close parenthesis. We have the string ABCD inside parentheses. Let's go through the steps. First, we identify the innermost parentheses, which in this case is the only pair. We reverse the string inside, changing ABCD to DCBA. Watch as we reverse the string. Now we remove the parentheses. Our final output is DCBA. That concludes example 1. Let's move on to the next example. Now, let's look at example 2. Our input string is open parenthesis U open parenthesis love close parenthesis I close parenthesis. We have a more complex structure here with nested parentheses. Let's go through the steps. First, we focus on the innermost parentheses containing love. We reverse this to EVOL. Watch as we reverse love to EVOL. Now we remove the inner parentheses. The string now becomes UEVOLI. Finally, we reverse the entire string. We remove the outer parentheses. Our final output is I love you. That concludes example 2. Let's move on to our final example. Now, let's examine example 3, our most complex case. Our input string is open parenthesis ed open parenthesis et open parenthesis oc close parenthesis el close parenthesis. This example has 3 levels of nested parentheses. Let's go through the steps. First, we focus on the innermost parentheses containing OC. We reverse this to CO. Watch as we reverse OC to CO. The string now becomes ed open parenthesis etco close parenthesis el. Next, we reverse the content of the middle parentheses, changing etco to octe. The string becomes edoctel. Finally, we reverse the entire string. I strongly recommend you to code along. Let's examine the Java code for this algorithm. Define the method that takes a string as input. Create a stack to store indices of opening parentheses. Iterate through each character in the string. If the character is an opening parenthesis, push its index onto the stack. If the character is a closing parenthesis, pop the last opening parenthesis index from the stack. Reverse the substring between the parentheses. Adjust the index to recheck the reversed substring. Remove all parentheses from the final string and return it. Now, let's discuss the time and space complexity of this algorithm. The time complexity of this algorithm is O(n)². The space complexity is O(n). the time complexity is quadratic due to string manipulations. Each reversal can potentially process all characters, and the string builder reverse operation is linear. For space complexity, the stack can store up to n/2 opening parentheses, and string manipulations create new strings.